So there's a couple different types of learning, particularly kind of offline and online or incremental learning. A lot of the learning that we do has traditionally been offline. People talk a lot about online learning, and they talk about it more than I think it exists in the real world. Trade-offs, right? You've got accuracy and adaptability of resources. So if we look at these, um, so I've got kind of a batch learning, which is offline typical, right? So I have a training stage. I take a bunch of data. I might do some feature extraction, some human labeling. I let ChatGPT write me up some machine learning code and deploy it, right? And then I deploy this model onto my edge hardware. So maybe I'm in charge of all of the Alexas all over the country. And once a night, I update the models on 10% of the Alexas to see what's going on. And then you have a smaller amount of data on that specific Alexa, like Alexa, turn on all the lights or something like that. It does some feature extraction. I don't know how they're doing their natural language processing, but it's my Alexa won't do it unless I'm connected to the internet, so it must still need the internet for something because people must know if my lights are on or off at the Amazon headquarters. Deploys it through that machine label and then kind of gives you your predicted labels, right? So this is kind of your batch learning or your offline stage. This is a very common way to do it. There's always a want to do things in an online method. So that's where you get into recurrent neural networks. Recurrent because you've got memory that's circulating around, right? So I have data, I have feature extraction, I have machine learning models, I have test output, right? And then I'm going to update my model. What you'll notice here is that I'm trying to update my model online as it's happening, whereas at the batch learning, I was only updating my model at a training stage and then just pushing a new model every time, right? But the model that was getting new data from like the customers wasn't getting updated. So you can do this in a loop and then you get a prediction. This is nice. It just requires a more robust model and a more specific application case. But it certainly can be useful. Um, I like this one a lot. This is the idea of kind of bad data and machine learning. You gotta remember that machine learning models, they recognize patterns and data, not concepts, right? So, like, and everything that I'm saying here is kind of like very generic, average baseline statement, right? So there's going to be caveats to all of this. There's people working in AI that, oh, we have this method that would do that. That's great. That's kind of not what we're looking at here. So it's kind of on average, we're looking at patterns and data, not concepts. So poor or biased data can get you the wrong conclusions. My favorite one is way back when they were trying to train some machine learning models to recognize cows. So they feed it in a bunch of pictures of cows, and it was doing great. And they would feed it in a picture of like a duck, and it would say it's a cow because it didn't actually recognize cows. It just learned to recognize the grass because every picture of a cow has nice green grass behind it, right? I like that they kind of humorlessly. The good thing about computer science, they can have a good sense of humor. We'll just call it shortcut learning. We're not wrong, all right? We just need to rephrase this.